Okie dokie. This is homework 5 for 1026 on direction fields and Euler's method. I do want to say, like, pretty much all this direction field stuff are like, they're basically the exact questions that used to be on the Math Emporium stuff. So I have videos for pretty much these same questions. I'm still going to make this video, but check out the playlist that's just called direction fields. I think it's just called direction fields, and then in parentheses homework 5. So we're still going to do this though. So starting with this, they say you have the table of values for a differential equation. What's the slope field that corresponds to the table? So for these different intersections of t's and y's, so when t equals 0, y equals 1, we have a y prime value of 0. What these are y prime values. Y prime means derivative, and derivative means slope. So we're really going to interpret just a bunch of these values in here just as slope values. So one other thing I want to say is this array of y prime values or slope values should match up accurately to like this array of slope field lines. So we should see a slope of 0, 0, 0 across the top, meaning bam, 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 like all flat slopes. So these aren't all flat slopes at the top, these aren't, but these are, and these are, and none of these are. So just like that, we can narrow it down to C and D because those have 0 slopes across the top. Then in the middle row, we're looking for a slope of 3, a slope of 2, and a slope of 1. So maybe something like this, then a little less steep, then a little less steep. And so that's looking like option D and not C, because C has the negative slopes in the middle, so D is our answer there. Let's keep it going. They say, what's the differential equation for the given slope field? So when you look at all these slope lines, what do you notice about the slopes of these little tick marks? They are all negative. So first thing to ask yourself is, like, is it positive? Is it 0? Is it negative? These are all negative. So right away, you don't want them to be 0. You don't want them to be t or y. So if they were t or y, they'd be changing dependent on whatever y and t are. So for example, the y values are negative down here, the y values are positive up here, which means y prime equals y. If y prime was equal to y, we'd be looking for values that are changing dependent on the y value. So say at -3, all these slopes would be -3. And then at -2, they'd be a little less steep, but still negative. And then once they hit 0, y equals 0 means 0 slopes. And then for y equals 1, it'd be positive 1s. And so it's changing dependent on the y values, right? And then likewise for t, it'd be changing dependent on the t value. So the first, like, all these would be 0 because t equals 0 along the y-axis. And then when t is equal to 1, you'd have slopes of 1 all the way down. And then it'd get steeper and steeper and so on. So that's for y prime of t, or y prime is equal to t. Anyway, in this case, they are all consistent. They're all constant slopes that are negative, so it's got to be -2. All right, let's go to the next one. What's the solution for this using that initial condition? So 0 and -3. So what they're giving you is an ordered pair, a starting point. And I believe all these graphs start at 0, -3. So that's nothing crazy. However, it would be helpful to go ahead and plug in that ordered pair to get a y prime value. So 4 times 0, and then plus y would be -3. So really right off the start, it should have a y prime or slope value of -3. So meaning, like, from this starting point at 0, -3, it should have a slope of -3. And so A does not. B starts with a positive slope, so B does not. C does start with a negative slope, so that's looking pretty promising. Let's see what else. F starts with a positive slope, so that's not it. E does start with a negative slope. That's looking pretty good. And then D also starts with a negative slope. Maybe not that steep, though. Let's see if we can pinpoint anything else. So what differences do we notice here? It looks like eventually E turns around and has positive slopes, where C and D do not. So the question would be, could y prime ever be positive? Well, it looks like, let's make an estimate here, maybe like 2.7 on the t-axis and 0 on the y, right? So if we plugged in, what that means is if E is our graph, then if we plug in 2.7 for t and 0 for y, we should get just a very positive slope. And I mean, that's looking promising right now because that's at least 13, no, not 13, like 9 something, a little over 10, I don't know, 10 or more. So that's a very positive slope. So maybe there is a chance that that is our answer. But let's see, it's going to take a little bit of process of elimination. So basically, the idea here is plugging in different t and y values will give you different y prime values. So it's like, can any combination of t and y give us positive y prime? And again, like this confirmed that the slope could be positive, but it was dependent on whether E was actually our graph. So let's see if just like any of these make sense. Let's see. So we're going to test different values here on these different remaining options. So let's say 1 and -4. Could plugging in t equals 1 and y equals -4 give us something valuable? Y prime equals t equals 1, y equals -4. Well, this gives us 4 minus 4, which is 0. So I'm going to go ahead and say, even though this is like a real rough estimate, I feel like the slope should be more, like it should be closer to 0 at 1 comma -4 because we're getting a slope of 0 down here. And so I'm going to go ahead and just disregard option D. What do we notice about C? It's a negative slope, but it's also a constant negative slope, which makes me think that y prime should just be a constant negative number. Like, let's say it started as -3, but let's say it stays as -3. It's probably just gonna like not be changing if it's looking like this. Does that make sense? Like, if it's a constant just decrease at the same slope, then y prime probably looks constant. So just based on process of elimination, I'm going to have to go with E. I'll be honest, this is not a great question because we can't, like, we're not given more information about the points. It's like a very guess and check process of elimination question, but I believe E would be the answer here. All right, let's not waste more time. Let's keep going.